All right, welcome back. In this class, we're talking about fruits. This is always a fun one. It's also a little complicated. Like in all things botany, there's lots of terms and classifications and things like that. I'm going to try to keep it simple, maybe make some generalizations, but you know, we'll find our way through this. What are fruits? So fruits are a mature ovary, technically, not always the ovary. So again, right off the bat, we're looking at some qualifying terms, but fruits involve the ovary, that is for sure. So in this picture of a peach, we have the seed in the center of the peach. I'm sure you're all familiar with the peach. That seed has the endosperm, which we often refer to as a cotyledon, the embryo, which is the immature plant, and then a seed coat. In the case of a peach, that's a really tough seed coat. And then immediately outside that, we have the endocarp, and then the mesocarp and the exocarp. So the toughest part of that peach pit that we see is actually the endocarp, and the seed coat is inside of that. So you may have had a split peach at one time. You open the pit and you'll see the seed inside, and there's a second. That's the seed coat that you see there. The peri or the endocarp, which is the hard exterior of the seed, is part of that exterior pericarp. So, so you should remember this slide from when we discussed flowers just recently, and the attachment of the ovary and its position relative to the perianth starts to play a role when we start talking about fruit. So superior, inferior, partially inferior. Never mind the hypogynous, epigynous, and all that. We'll stick to the superior, inferior, and partially. It's good enough for what we're doing. So keep this in mind as we go through this lesson about where the ovary is relative to the perianth and the receptacle in particular. So when we're talking about fruits, just a reminder, we have the ovule and seed and fruit. So we're looking at three separate things. So uh, kind of keep that in mind as we go through this, because the ovule being the immature seed or the female gametophyte, and the seed is a fertilized zygote. Then you have your cotyledon and the seed coat. And then, of course, the fruit, which is the aggregate of the entire thing, uh, is the ovary wall. So if you imagine your stigma style an ovary, and you've got fertilization of your ovule, you get seed development within the ovary, and then their surrounding ovarian tissues begin to swell in certain circumstances and form the larger fruit. So again, looking at the peach, those are the layers roughly that we're talking about, right? And when we talk about pericarp, we're talking about outside the ovary, endocarp, mesocarp, exocarp. A couple more terms. They will make sense in a second, so let's go over them. This is just a real rough sketch to sort of outline what's inside the ovary. So the ovary cell wall, and we have the locule or chamber, and remember that one. That's the space between the ovary wall and where the seeds are. This is the locule, this chamber. And then there's the actual uh, seed, which we see in the fruit. A good example would be if you take a pepper, like a bell pepper, and you cut it, you can see that here's your locule. These open spaces are your chambers or your locule. And these are the ovary walls on the exterior, right? And the seeds, which are all around the inside of your pepper, are attached to the center piece of the ovary via the funiculi. So again, just so you can see the process with the pepper, we start with the flower. These happen to be bee pollinated. The petals turn in and fall off, and the ovary starts to swell, and then it begins to enlarge further, and then we have a ripe pepper with all its various seeds and locule chambers and swollen tissues in the ovary walls. So that's just sort of a brief introduction. So obviously the first the plant has to mature, then we have to have pollination, and then we have to have ripening. That's the process. I think by now you see that. This link here takes you to a video on pollinating cucumbers, which you might find interesting. There's lots of videos about fruits because people are fascinated by them, so no shortage. Um, so when does fruit set? So I talked about how the plant has to ripen to an age, a maturity where it can reproduce. Uh, that age is interesting, and we sort of have two divisions in how plants progress towards reproduction. One is called indeterminate growth, and the other is called determinate growth. And it's important you remember the difference between these. Um, the classic example I give is in indeterminate growth, the plant starts as a seedling, it grows to a reproductive developmental stage, begins to fruit and flower, and continues to fruit and flower until it is terminated by some external force, like winter or death from insect infestation. Basically, just continues to grow and grow and grow and fruit and fruit and fruit. Um, Whereas determinate growth, typically the plant starts as a seedling, grows to maturity, fertilization, and then has one giant single flush of fruit, and then the plant is done. So that could be that it reproduces annually, or it's a singular event. So I like to talk about tomatoes, for example. Tomatoes, we have vining tomatoes, which we take advantage in greenhouses. We can get them to fruit non-stop until we terminate the plant, where often tomatoes grown in fields are determinate plants that will grow and fruit and produce a large flush. The difference is that the vining tomato has a steady production of fruit, and the determinate plant has a huge, big flush, singular event of fruit for the most part. So you get gradual production or a singular pulse of production with determinate growth. So a plant that grows, right, produces flowers until it's killed is indeterminate. And determinate would be one that produces a single flush. So again, going back to the beginning with my little drawing of the locule and ovary, together we call that entire structure a carpel. So all fruit develops from a carpel. So here's just a few examples of watermelon and apples and tomato flowers and how they form fruit. But essentially, we're talking about the stigma style and ovary, right? So in this case, the entire female reproductive structure of the plant. Here we have a zucchini plant that's been cut, and we can see there's the stigma, style, and then there's the ovary. And there's many seeds in here, each one led to from a single pollen that pollinates it, right? Typically, we grow sterile ones that are just not fertilized so that you don't get seeds. Um, so the carpel consists of stigma, style, and ovary. All right. Sometimes there's just one carpel. Sometimes there's many. They typically are fused, not always. But when mature, that's the fruit that we eat. So let's talk about the different kinds of fruit. So we have simple fruit, aggregate fruit, multiple fruit, and accessory fruits. Simple fruits develop from one carpel or several, in the case of a tomato, for example. Aggregate fruits develop from several carpels that are fused. You think of a raspberry, if you take a raspberry, you can kind of peel it apart and you get lots of little round bits out of it. Each one of those is a carpel, and they're sort of plugged onto the receptacle, which would have been from the raspberry flower. So in the case of an aggregate fruit, you have several carpels fused onto one receptacle. And the raspberry is a really good example of, how you can sort of plug it on, plug it off. Multiple fruits develop from more than one flower. So unlike a raspberry, which had a single flower with compound ovaries that turned into individual fruits on the receptacle, in the case of multiple, we have entirely separate flowers on a stem. And as they mature, they fuse together to form a singular structure. And in this case, the example is a pineapple. So if you look closely, each hexagonal flower grows along a central stem. So this central part, we often cut it out because it's woody, right? Well, that's because it's a stem. Uh, and the surrounding tissues become part of each flower. That's why we call them multiple. So each one of these is an individual flower from this compound flower that we see up here. Technically, pineapples are also an accessory fruit. I'll introduce that. We're going to talk about it throughout the lesson because there's really not a lot of convenient places to discuss it individually because it overlaps. So this would be an accessory fruit because it is using something like this stem and the receptacle as part of the entire fruit structure. So there's accessory tissues involved. So keep that in mind. It's a multiple, but it's also an accessory. So as we look at accessories, the classic example is strawberries, but many examples exist. Apples exist as well. Even though they have separate classifications, they are also accessory fruits, which means that they primarily develop from tissues near the ovaries, but not exclusively the ovaries. Okay, so they can involve the receptacle, the pericarp, or the perianth in their development, which would classify them as an accessory fruit. The ovary wall, so the key here is the ovary wall does not make up a significant portion of the fruit ultimately. Okay? So moving on to simple fruits, we can divide them further into both fleshy fruits and dry fruits. Okay, so if we look at fleshy fruits, berries is a really good one to start with. We'll go through all of them. Berries develop from several carpels, but the key defining characteristic of a berry is that it has many seeds. So it's fleshy and it has many seeds. So blueberries, I don't know if you've ever actually opened a blueberry. The seeds are so soft when you bite them, you don't realize you're eating. But there's like hundreds of seeds inside the center, and they're really soft. Peppers, we already talked about that. Another really good example of a berry. Uh, this is always the one that people like to talk about. Tomatoes are berries. In this case, it's actually, you can see uh, that each ovary chamber or locule is well defined when you cut horizontally through a tomato. And of course, we know there's lots of seeds, many seeds, so we know it's a berry. And of course, it's a fruit because it involves the ovary, right? I know that we have in our minds vegetables and fruits, but yeah, tomatoes a berry. Same thing with kiwi. That's pretty straightforward. We know there's lots of seeds in there. Another type of simple fruit is Hesperidium. I've always liked this name. It's kind of a fun name. Hesperidium is any kind of berry, meaning many seeds, with one or fused carpels, but it also has a leathery rind. So pomegranates, all of the citrus family, they are Hesperidium. Pepo, another fun one. I think if I got another dog, I'd name the dog Peppo. It's just a good dog name. Anyways, they have a hardened rind. So this is, your acorn squash, your melons, they are berry-like because why? Many seeds. Look at all the seeds, right? We just finished carving pumpkins. We know all about seeds. Um, the entire cuke family basically is Peppo. So pretty easy one to remember. Droops. This one always reminds me of the cartoon Droopy, but I don't think you guys would know who I'm talking about. It's a dog with long ears. It's kind of just whines. Anyways, droops are developed from one to several carpels. Okay, we've talked lots about carpels. They typically only have one seed. And of course, the inner layer is stony. The best thing here is just think of all your stony fruits: your apricots, peaches, nectarines, plums. So they have an outer fleshy layer and they have an inner stony layer. All right, those are your droops. Pretty straightforward to remember. Now, this is an interesting one. Palms, which are, like the apple, French for apple, pomme, they are accessory as well. So pomme is a simple fleshy fruit, and it's also classified as an accessory fruit because It develops from, oh, here we go, inferior ovary. Remember we started off with that, right? So the ovary is below the receptacle. And the fleshy portion, the apple part that we like to eat, comes from the perianth, right? So if you look at the picture over here, you can see that the seeds are forming down into it. The ovaries push down into the receptacle, and this entire structure around that area is what turns into the fruit. So the sepals are just attached to the exterior, and all these things become engorged and filled with tissues that we like to eat as an apple. But if you look at the cross section of an apple, the ovary walls are here, and they do not involve much of the fruit. Whereas the perianth involves the majority of the fruit and the receptacle. Receptacle being the majority of the perianth in this case that we're talking about. So the apples are also an example of an accessory fruit, but they have their own category as palm. So if we look at simple dry fruit, so that was fleshy, let's move on to dry. There's two types of dry fruits. There's dehiscent and there's indehiscent. And the difference being that when the entire ovary matures and dries, because this is dry fruit, when it dries, if it's dehiscent, it means it automatically breaks open and releases seeds. If it's indehiscent, it matures and dries, but it does not automatically break open. It needs some sort of external force to crack it open or to blow the seeds off or something along that line. So dehiscent fruit, when they're mature, they break open and the seeds are released. So we're going to talk about the different types: follicle, legume, calyx, capsule. So follicle, uh, these form from a single carpel and they split on only one side. The classic example is milkweed, as you see over here. It looks almost like a boat, like a canoe. Uh, and inside each seed is attached to sort of a cottony substrate that helps them to fly through the air. But these will open and mature and force those seeds out into the air, as you'll see in the image here. And from there, the seeds will fall and float in the air. But the seeds are released by the pod. It's not that they're attached by some firm funicula still. Legumes. These are dehiscent. The difference between legumes and the previous one is that they split into two. So when the seed pods mature, they crack open and the seeds roll out. Now, what gets a little confusing is that a lot of the varieties that we see grown in gardens and by farmers have been bred not to split because they want the seeds, they want to harvest the seeds. So they've bred the plants to reduce that from happening. It doesn't mean it doesn't happen to some extent, but for the most part, those types of seed pods, they stay attached until the machine harvests them. But if you look at a more natural legume plant, as they mature, the seed pod splits open into two and the seeds roll out. Some pretty good, cool examples: Kentucky coffee tree, really big seed pod or fruit, which splits into two, and then of course the seeds can fall. Calyx, which is basically along the same lines as legume, except that they split into three. So it's hard to see down here. These individual pieces all make up the fruit structure. Typically in calyx, the centerpiece is a flat sort of lamina with the seeds attached to it, and then the outer two are like covers. So there's three pieces, but it's a central piece that has the seeds deposited on it. So the entire mustard family grows like this, or commercially canola. Sometimes you see the yellow fields. It's more out west these days. They are calyx. Capsule. This is where from a compound ovary, so there's multiple chambers. If we cut this horizontally and look down, it would look like a wagon wheel with locule chambers, just like a tomato, but dry, right? Um, these capsules typically form from both inferior and superior ovaries. So remember we talked about the position of the ovary in fruits. So capsules can form from both. The classic example is a poppy. Uh, each of these slots, when the fruit matures, they open, and then as the plant sways in the wind, the seeds can be knocked out, or if a bird lands on it. But they typically are considered dehiscent because the seeds fall out pretty readily. And here's you can see inside how many seeds are in there. They're not attached by a strong funiculi, so they're loose. And so they self-dehiss in that sense. This picture is just just clarifying some people think that's the poppy seeds that opium comes from. It's actually the sap in the ovary wall that they collect to make opium. It's craziness. So going on to indehiscent fruit. So these are fruits that do not dehiss. The first example would be a quine. So a quine is a single-seeded fruit attached by funiculus. So it's attached, right? So it's indehiscent. The seeds remain attached. The buttercup family, strawberries are often referred to as a quine because the seeds, the fruit, are actually on the exterior of the strawberry. All those little bumps, that's your strawberry seeds. I think you knew that. You probably thought that this entire thing was really, the fruit. Technically, the seed is dry and on the exterior. So you're looking at an accessory fruit there, to be honest. Just out of interest, sometimes you see strawberries that have young plants growing on them. The term for that is vivipary, where plants will spontaneously germinate their own seeds. It happens sometimes from conditions where the environment is really vegetative and the plant is confused, doesn't know if it should be producing fruit or growing more plants. Sometimes you see tomato plants will germinate inside the tomato. That happens sometimes, especially when the tomato is overly ripe. Um, Going back to the accessory fruit discussion with strawberries. So strawberries are a quine because we have a dry strawberry on the exterior, so dry seeds on the exterior. So it's a quine. But the fruit that we enjoy is actually derived from the receptacle and the pericarp. So it is considered an accessory fruit. The actual fruit we're talking about that strawberry itself concerns is the seed. It's a dry seed, all right? So dry, indehiscent, a quine accessory fruit. I know, it's complicated. Moving on to indehiscent samaras. It's another type of indehiscent, dry, simple fruit. Um, Samaras are often referred to as winged akene. The seeds are in the exterior. They're attached by funicula, but they have a wing, which means they need wind to disperse them. They do not automatically fall. They typically need a strong wind. Um, Examples here are ironwood and box elder. Uh, you'll notice that I don't have maple keys here. We're going to discuss that in a second. But so samara are what we call winged akene, dry indehiscent fruit. Caryopsis, this is your grasses and your grains. Uh, these are dry indehiscent fruit. So they are typically relying on birds to pick the seeds and disperse them. That's kind of a good strategy for covering a larger area. If you just drop your seeds, it takes longer to take over a given area of land. But yeah, Caryopsis are your grasses. So they are considered a quine-like because the seeds are attached by a funicula on the exterior. Cypsella, indehiscent, dandelion and burrs, your two classic examples. They are a quine-like because, again, the seeds are dry and attached to the exterior by funiculi. But they're indehiscent because they require wind or an animal to pull them from the receptacle or from the receptacle structure. Typically an inferior ovary. Nuts, indehiscent, dry fruit, stony fruit wall. Typically a compound ovary. So again, just like the pepper, you see how there's locules, right, on your ovary walls that have formed. So nuts are dry, indehiscent fruit, the compound ovary. Schizocarp. So this is an interesting one. This is because the seeds always split in two when they're mature. That's the key differentiator with schizocarps. They split into two at maturity. Celery is the classic example. There's two seeds here, two seeds. So it's a double ovary at the base of the flower. Now, this is why maples have been reclassified as schizocarp, because they are always in sets of two as keys, always in sets of two. And the botanists of the world decided that was more important than them being classified as samara, so they were reclassified as schizocarp. My last slide here, I've tried to summarize basically the rough layout of the fruits and the different types. There is a document in this week's folder below the PowerPoint lesson. I really encourage you to read that document. It's a really good summary because this can be a little confusing. There's a lot going on and a lot of terminology. This slide is just me trying to help you navigate what I talked about today. And of course, accessory fruits find their way throughout this tree here. So remember, we got simple, aggregate, multiple, and quote accessory. And then simple fruits are split into both fleshy and dry. And then dry fruit is split into dehiscent and indehiscent. And dehiscent dry fruit will self-release into the environment, where indehiscent requires some external mechanical force, wind or animal or birds, whatever. Okay? I think you'll enjoy the lab. Usually it's a lot of fun dissecting various fruits. All right, see you next time.